Welcome to my channel, and today we're going to be experimenting with the McDonnell Boilerwize FPC-1000 low water cutoff, which is designed to run on either 24 volts or 120 volts, and to be settable in the field to either run hot water manual or auto, or steam manual or auto. In this particular one, shout out to Nick Green of All Steamed Up LLC for supplying this unit, which has been burned in with the steam manual operation. And on the cover, it says that the status LED, when we power it up, will be a yellow LED, and it'll blink 6 times. If it was set up for hot water manual, it would be yellow, and 4 times, and so forth. So without further ado, let's go ahead and power this bad boy up. There are a couple of ways of doing it. We could either put the 2 terminals here where my finger is, and then on this, or we could use the Molex plug, which is designed for packaged boiler systems. I've wired the lights in to where the green is going to light up if the W relay is on, and that is normally a closed relay, and a burner circuit, or B, which I've put on with an amber light, which would send, in this particular case, power down to the primary low water cutoff. So let's use this Molex plug here to wire this up. Red is burner circuit, white is neutral, and the brown in this particular case is the hot. So I'm going to go ahead and put that in. I'm going to go ahead and hook it up to our 24 volt transformer. And let's take a look at the LED circuit when we wire it up. Oh, hey, a little spark there. Shout out to Electro Boom there. All right, so you can see the green light comes on, goes through a self-check, and there were 6 blinks, and now it's going to blink a couple of times and then lock out after about 30 seconds or so, and will not be resettable. You have to push the test button to get it to reset once you restore water. So we've wired, there's the probe, by the way, which you would not normally see this portion of the show. And now we're locked out. The green is on, the burner circuit is not. This is generally why you do not want to wire up a water feed circuit to a manual reset control, because then it would flood the boiler. So let's go ahead and simulate water to the system. So we're going to ground the chassis, or rather we're going to attach a clip to the chassis, which is ground. You can see the ground wire here. And then we're going to clip it onto the probe end of the unit. Now that winds up right here and goes into the circuit board. So we're going to go ahead and hook that up. Now nothing happens because this is set in manual, so we have to push the manual button to get it to reset. Watch it, and then release. Now it's going to go through another self-check. And now this is going to, it doesn't really like that. So what I've discovered on this particular circuit, particularly with McDonnell, is that it really doesn't like a low resistance short to the probe. It wants to see some resistance. So one way of doing that, see if I can move this over, is to use this resistance decade box to supply the resistance that we want. So as you can see, it's just going through its checkpoint there. So we're going to go ahead and take that off, put it here, And we're going to supply, I've played around with it, and it needs to see about 23 units, ohms. And you can see the burner lights up immediately. If we were to try to take away that, let me see, I meant out, I meant, yeah. Let's try that again. Let's break the circuit. And now we're going to put it back in. We'll see if it, okay. Sometimes it'll work, sometimes it won't. It's very tricky. As I said, I've played around with this, and sometimes it will be resettable, sometimes it won't. But I found that if I put at least 23 ohms of resistance from the chassis ground to the probe, that it seems to become reasonably stable. So let's go ahead and feed some resistance across the circuit. So we got 4K and no response. We're going to add 3K to the 4K, and that'll give us 7K. And there's no response. So let's add another 1,000 ohms to this, and we'll see what happens. And it doesn't like it. It's determined that, you see that it didn't take very long for the burner circuit to drop out and the alarm circuit to come back on. And this will blink for about 30 seconds in total, and then will become solid red and will lock out. All right, so now even if you restore the it's not happening. It's having none of it. You have to push the reset button to get it to a reset. Goes through a reset process. And back again. Add, let's just say, yep. So that's 4, 5, 6, 7, 8, 9, 10. Yeah, it's still not. Okay. You can play around with this, and you can get, it's something a little over 7,000 ohms before it becomes unhappy with the resistance. And that's what you're essentially measuring, a resistance to ground or chassis ground, as the case may be. Well, I hope that was helpful. And I'll see you on the next one. You take care.